Good afternoon, everyone. I'm Josh Boyd. I'm a chief technologist at Booz Allen.
Steven Tarana. I'm a lead technologist at Booz Allen.
This is a talk that was not originally accepted here. We gave this talk at Red Hat Summit, about a month ago now, I guess?
Yes, sir.
And everybody liked it so much that we thought we'd bring it back and show it to you all. So let's go to the next slide. We'll just jump right in here. No agenda slide anymore. Get rid of that. So what are we going to talk about? We're going to talk about our what we call the solutions delivery platform. So this is our approach as part of our modern software delivery approach to delivering applications, infrastructure, data science workloads through kind of a universal CI/CD process. So if you look here at the middle, you see DevSecOps is kind of at the middle of everything that we do as a firm when we do client delivery, right? So surrounding these things, we talk about automation, we talk about learning, continuous security, open performance. You dive in a little bit further, and we see kind of our four key tenets, right? User-centered design, microservices, open tech, and agile, right? And these all lead into that DevSecOps piece. So the thing that we've built takes all the ways of how we do work and makes it so we put it into one place, shove it through one pipeline, and make sure that we're able to deliver it at scale and at speed, right? And I'm going to go a little bit quick so that Stephen has time to show you his demo. Right, so an important part here at the top, right, you see these autonomous delivery teams. So something that's kind of interesting that's happened as part of Kubernetes and OpenShift and cloud and even CI/CD is that we're able to now have these teams that are made up of developers, of sysadmins, of testers, of security engineers, right? And have those be kind of our feature delivery teams, right? So now I have a product that I'm developing, I have multiple teams, and instead of having a security team, a 508 team, a ops team, right? What happens if I just kind of smush all those teams together, right? What happens? Well, what happens is we're able to start executing and delivering business value much more quickly, right? We have the team owning everything from inception of the issue or feature all the way into production, continuous monitoring, continuous delivery, all that fun stuff, right? So we get to deliver more quickly, we get to fix bugs more quickly, we get to have environments that are more stable, that match each other, right? Because we're doing this cool infrastructure as code and automation and all these fun things, right? And then we just get more into like, what are the benefits of doing this type of automation, right? So basically, we get this happy path and everyone's happy along the way once you get to this nirvana land of implementation, which is part of what the solution that we've developed helps to hopefully deliver to our clients. So what we see here is how this team is kind of built up. On the left side, right, we have kind of a smorgasbord of a pizza-sized team, maybe a 2 pizza-sized team if you guys are hungrier than one slice each, right? Over here on the right side, right, we do Agile in all of our projects. Open tech is interesting, right? Open tech doesn't necessarily mean open source, right? So open tech can also be that we have standards, that we're defining APIs, that we're defining integration points between things, but that we're bubbling those up so that's open across our teams. It doesn't necessarily mean that everything we're consuming is open source and that we're using open source technologies everywhere. And then down here at the bottom, what we're seeing here is a few pieces of what we think DevOps kind of boils down to as far as practice areas, right? So we see continuous integration, continuous delivery / deployment, right? Continuous deployment is what happens after I trust continuous delivery for a while, right? My automated tests are working, I'm not seeing build failures into staging, and my product owners and business folks start trusting the code my teams are writing, right? So that then I can go to production on commit. Automated testing, continuous monitoring, all that continuous stuff, right? So, is this one we call money slide now?
This is the money slide.
This is the money slide now, right?
If you were going to take a picture of the slide, this is the slide to take a picture of.
Yeah. Right, so what's the point of this, right? So a lot of folks talk about a trusted software supply chain now, right? So we do all this open source stuff, we do all this open source governance, we're moving more quickly, right? So we introduced some risk, right? We introduced risk of security. We introduced risk of delivery. We introduced risk of bugs. We introduced risk of just doing things wrong, right? So how do we reduce that risk? Well, we reduce that risk with that trusted software supply chain and with a DevSecOps pipeline, right? So we do have all those practice areas that I talked about that we consider when we approach DevOps or DevSecOps. And we bring all of those concerns to the left as much as possible, right? So what happens normally in a project is that I build my code, I push my code into QA, and then maybe in a month or two, I get a report back that says, you failed 508 testing, or you failed a security scan. You have a higher critical, you're not going into production, right? And so then we go back to the beginning. Well, I've already started feature development on something else, on a new branch, if hopefully I'm somewhere where I have a source control system that allows for branching, right? And then I figure out how to fix that thing and submit it back through the process and repeat, right? So how do we make it so that developers know as early as possible that your code's wrong or broken or your feature isn't going to work, right? And that's really what this slide is covering, right? And what are all the integrations with all the types of tools that exist now that we can do to make this happen as quickly and as early as possible. So on top of just development best practices, right? Like committing regularly, like not waiting until I finish my feature development on my machine after 3 weeks to commit code for my feature.
At 5 p.m. on a Friday.
5 p.m. on a Friday, right? How do I now make sure that my developers are doing this kind of culture change to make sure that they're developing and committing regularly, that they're making PRs regularly, so that then all these things run in continuous integration and I don't have a nightmare as a developer or a product owner when I try to integrate all those things at the end. Skipped one.
I skipped one.
So this is what a pipeline looks like, right? This is what a complete integrated pipeline would look like with all the different, well, no, not even all the different kinds of testing that you would be doing, right? This is just a sampling of the testing that's required for you to get to the point where you feel comfortable with continuous deployment, right? Wait,
Gotcha.
That's a lot of stuff.
That might be different per tech stack that you're using.
Right, and it can be different for every stack, can be different at different organizations, but this is probably a minimal representation of everything that we feel like you have to do to be comfortable in that the code that you are pushing is good code, right? So we would build this, and many other organizations do too. You would build a new pipeline and new integrations on every project that you go into, right? So we get an engagement at USCIS. We go in, well, USCIS isn't a good example. They already have a pipeline that they use organizationally. You go in there and you have to build a new pipeline for your project, right? And it takes maybe 3 months if it's a good experience and you've got all the tools there already.
After you stand the platform up.
Right, after you stand up a platform. You build out all this stuff. So we were doing this over and over again, right? So in response to that, we said, hey, let's build this universal DevSecOps pipeline that's pluggable, has shared libraries, that we can swap tools in and out because we've made kind of some decisions about what APIs between those tools and their integration with our, in this case, Jenkins looks like, so that we're able to rotate a little bit if conditions change depending on what projects we're going into. Stacks change, platforms change, right? Now we can go to your part.
So our solution to that problem of reinventing the wheel every time we start implementing DevOps practices that are with our different clients is the solutions delivery platform. So the solutions delivery platform is broken into 3 components or tiers. You've got your container orchestration platform. We've sort of been galvanizing around OpenShift. Then you have your DevSecOps universal plug-and-play pipeline. This is the piece that lets you use a single pipeline for an entire organization or agency, regardless of tech stack. It abstracts out the pipeline definition from individual repositories and gives you that organizational governance to be able to define business processes for your entire organization. Then on top of that, we are generating all this data while we're doing our software development as features are being pushed out. What if we could aggregate this data into a DevSecOps dashboard to be able to gain insights into where the bottlenecks in our process are, what quality looks like. Now that we're moving more towards microservice development, we've got this application is now comprised of multiple applications that could be spread out amongst multiple teams in different locations. How do I get a picture for what quality looks like on the big picture as an organization. So the solutions delivery platform, we're going to talk a lot about the middle piece there, how we built this universal pipeline. It's broken into 4 phases here. So you've got govern. So you have the organization defines the configuration for their pipeline. What are the tools that are being universally used by every application development team that is a part of my organization? And they can do things like conditional inheritance, where I can say, I'm comfortable with this particular tool being swapped out by different teams. I'm okay if these, different toggles around quality get switched on and off. It's really up to the organization to define what does our business process and governance and quality gates look like for software development here. After that, you've got the tenant configuration. So based on what my parent organization said, so now I'm a individual microservice team. Based on what my organization has said, what can I configure and what's customizable? And let me configure the pipeline specifically to my use case. Then you've got composition. So I said that we can use a single pipeline for an entire organization regardless of tech stack. That's because the pipeline's been broken up into generic phases. Everyone, regardless of tech stack, is going to build, compile, unit test, build a container image maybe, do penetration testing, static code analysis, all of these generic things. What if we could swap out tools for each piece of that and let the individual tenants define which specific tool is going to do this part of the pipeline? So the organization says, you have to do static code analysis, but they might leave it open. Some teams want to use SonarQube. Other teams might want to use something like Fortify. And then finally, the pipeline execution. So this is, we've got these configurations. We know what the business process is for this organization. Let's combine it all together and execute a pipeline. So what's stopping you from doing this yourselves? Absolutely nothing, but it's very hard. We literally had to change Jenkins itself. I'm a newly minted Jenkins contributor because we had to fix Jenkins to enable this dynamic behavior we're talking about.
Enhance Jenkins.
Enhance Jenkins. We need to enhance Jenkins. And then on the right, there's all the fancy software engineering terms that describe what's going on under the hood. But the beautiful part about SDP is that to the end user, you don't need to know these things. You're able to add tools by adding a new library, or as a developer, you're able to just create your repository, and your pipeline is integrated after adding a configuration file. So, wow, the screen's light, but there's text there. But this is to, I promise. But this is to show what your pipeline definition looks like with the solutions delivery platform. So what typically happens is, one team in your organization starts doing DevOps principles. They're adding automated testing. Over time, they start to add more. What was a 50-line file turns into this 750-line spaghetti code of a pipeline definition. The organization says, wow, that's really impressive. Let's scale it to everybody else. And they say, well, I hard-coded this for Node, and it's got to use SonarQube, and we're deploying to these application environments. And let's say they said, this process that's defined in the pipeline, let's change that up a little bit. Well, you've got 750 lines. It's not going to be easy to tell how to change what happens when I make a pull request to this place, what happens. Whereas on the left, you have a pipeline definition with SDP. It is something like a 13-line file that reads as plain English as possible that says, when I do things in GitHub, things are going to happen in my pipeline. On commit, we've got continuous integration that's dynamically defined by a config file. On pull request, and I can use regular expressions to say branches, I'm going to run that CI again. I'm going to deploy to a preview environment. And then in parallel, I'm going to do all these kinds of automated testing that we talked about on previous slides. And then, assuming that passes, I can merge the pull request, and it's going to deploy to production. So the value here is that if I wanted to change over time what happens when in my pipeline, it's 13 lines. You can very clearly define new regular expressions, change what's going on when. So this is the foundational principle of SDP, of being able to swap tools in and out for different pieces. So let's say, for instance, I had something that said scan container image. What if what if the pipeline called a method, scan container image, and then depending on which library I load, different libraries will implement that same method. So if I load twistlock, for instance, I'm going to use twistlock for container image scanning. If I load OpenSCAP, I'm going to use that for container image scanning. So based on the configuration files we talked about earlier, whichever libraries you specify are going to inject their own functionality, and you'll be able to compose a pipeline at runtime. So this is the organizational configuration file. You're defining things about your organization that get inherited for the entire agency and how you do software development. So this is going to define things like application environments and stages. So there's that dynamic continuous integration method. And then on the right, you've got your library definition. And this is going to read a lot like your tech stack. It says you're using GitHub Enterprise, you're using SonarQube, Twistlock, all these different tools that make up our specific tech stack. We're loading them in here, and this is going to determine which tools are used for which different pieces of automated testing. All of these libraries have sensible defaults so that you inherit best practices around you should fail to build if SonarQube's quality gate fails, and if your tests fail, you should probably fail to build. But we know that organizations all are different and have different situations, so everything in here is configurable and configurable down to the individual development teams. So if I wanted to say, it's okay with me if you customize the enforce quality gate, you can overwrite that yourself. That's customizable. The organization can say, I'm comfortable with them doing that, but for these other fields, I'm not. And now, we talked about this earlier, this is your organizational pipeline definition. You can have one or many. You can say, this is my Jenkins file for my entire organization, or you can have multiple templates that say, this is my front-end pipeline and this is my back-end pipeline. Because of how dynamic it is, I personally haven't seen a use case for it, but it's there. And it's incredibly easy to change as your process matures over time. Maybe your pipeline will too. Then the tenant configuration file. So if I'm loading a tool like Ally for 508 testing compliance, you need to tell it what environment, what's the URL I need to test against. In most cases. Earlier today, we demoed ephemeral application environments, and that dynamically supplied that value for us. But a lot of times you have a dev, test, staging, production type of pipeline. You just configure which URL is being used for which tool for the automated testing to take place. And now a live demo. I don't know if I can say the same joke 2 times in a row, but cross your fingers for me. So here is OpenShift. In this case, deployed on AWS. While I wait for the internet. Here we have Jenkins. So we talked about a single pipeline for an entire GitHub organization. So every single organization, every single repository, defined within our Red Hat Summit. Like Josh said, we're borrowing the demo from Red Hat Summit, but every single repository in here will share a pipeline. So this would be all of your different microservice development teams, all inheriting the same pipeline. We have our DevOps tooling deployed on OpenShift. So we have Jenkins, and we've got pods for distributed build agents, SonarQube. So now as an application developer, how do I interact with the solutions delivery platform? If I have my front-end application, I can branch off of master. I'm going to edit the README so that I don't break anything. And I can create a feature branch. When I do that, I can go create a pull request. And when I do that, that's going to automatically kick off a job in Jenkins. Zoom out. So this kicked off our pull request. The blue ocean view is more aesthetically pleasing. So while this is kicking off, let's go back and look at that front-end repository. Within here, you will not see a Jenkins file, and that's to reiterate what I said earlier, that definition has been extracted out to a single location in a pipeline configuration repository where we define what was on the slides. In our case, for this repository, all that had to be defined was what is my organization, and it's Red Hat Summit. Within the next 2 weeks, I will make it so that it matches the organization's GitHub name, so you don't even have to put that. And now, without any configuration file, you were able to have a full DevSecOps pipeline just by adding a repository to your GitHub organization. So going back to Blue Ocean, we're now going to kick off all the kinds of testing we showed on the money slide. So that's static code analysis. We're going to build a container image, and then we're going to scan it. We're going to create an ephemeral application environment, which means we're going to take a copy of production, deploy that, and then just swap out the feature that we're testing right now. And then against that ephemeral environment, we're going to do all of the kinds of testing like 508 compliance, functional testing, penetration testing, everything except load testing, because an ephemeral environment is there to test your integration points. So while this is running, I can pull up SonarQube. So Sonar Cube is going to do static code analysis for you. So here you're able to drill in and look at particular code smells, and it goes deep enough to show you exactly what the issue is and give you examples of how to fix that and what causes that particular rule set. For every tool that we're demoing today, there's a concept of policy enforcement. So you as an organization get to define what does fail or pass mean for these different kinds of automated testing. And then if your microservice doesn't meet those standards, the build has failed. So just by getting through this process, you're able to assure the stakeholders the code that you've written passes all of our organizationally defined policies for code quality and security. So now that we have deployed to this ephemeral environment, it's now going to kick off Ally for 508 compliance testing, functional testing, and penetration testing. I put a pause in here just to show the ephemeral nature of it. So if we go back to OpenShift, we're able to see that a OpenShift project was provisioned just for this pull request to test the compliance and security. So if we go back to the pipeline, these are all executing. As soon as OWASP finishes, I will be able to download these test reports and show you the quality that's been found for each of the different tools. Cool. OWASP sometimes takes a little bit longer. While that finishes up, I can show you that we're using Helm for deployment to OpenShift. We have values files that determine our infrastructure as code for the entire environment. We don't have to dive too deep into that right now, but the point, though, is that every container image that gets built gets tagged with the commit SHA, which means that we're able to say, this source code, this version of the source code, is deployed to each application environment. So we get very fine-grained auditability of what code is deployed where and how long has it been there, who did it.
What's the PR look like while Jenkins is running?
Sure. So the pull request, DevNation front end. Thank you for that reminder. You can't merge this pull request until the automated testing has passed. So this prevents you from committing broken code that's going to inhibit the velocity of your fellow coworkers while the build is broken. So again, this is another thing that ties into that automated provenance of the code has been reviewed, it's been quality tested. We're confident that this code is ready to go to production.
So now, as a developer, right, I don't need to know anything about Jenkins. I don't need to go anywhere else. And I don't need to really understand where I'm deploying to anymore, right?
Exactly. So without any configuration at all we had to do is add that repository and a one-line configuration file. We did static code analysis, container image scanning, 508 compliance, and penetration testing with no configuration on the application developer side. We're going to work with Jenkins to make a nicer user interface for this, but the test reports are all archived. So each of the tools that we talked about generates some output of what they generate. So I can go open my 508 compliance tool, and now I'm able to see all of the 508 warnings that have been identified. It crawls the application so I can see each of the different endpoints and then see the errors and warnings for each of these.
This is you as a developer?
This is me as a developer or as a security team member. I think an important part of DevSecOps is integrating security into the whole software development lifecycle. So the idea here is that you got to the end of this pipeline, you did all this testing, now your security team is involved in the process and can say, these are all the test reports. By the fact that you got to this part in the pipeline means you already passed our organizational quality gates. Now take a look at the reports if you need to and approve the deployment to production.
Is this your dashboard, I guess?
So this is an HTML report that was generated by Ally itself.
So a piece of what we're doing now is we're now working towards gathering those artifacts and using them to generate documentation, ATO packages, and figuring out what kind of dashboarding solution makes sense for kind of an integrated view into all these tools instead of having to go into them individually. Whether that's something in Jenkins or another tool, we're not quite sure yet.
So now that the pull request, the PR job has passed, I'm able to merge this pull request. When I do that, by referring back to my definition on merge to master, we're going to deploy to production. So that concludes the demo. Lost my train of thought. That concludes our demo. We did all the organizational governance. The important takeaways are that we used a single pipeline for an entire organization. regardless of tech stack. You abstracted out that business process from individual development teams. So as a rogue actor, I can't go modify the Jenkins file in my repo, say, skip all these tests, I want to deploy to production, because it's designed, defined centrally for entire organizations.
I think there's 2 more slides after the demo. Yes, dashboarding. So for a while we worked with the Hygeia dashboard from Capital One to integrate into all these different tools. It's kind of on the back burner for us right now. We're kind of bringing it back now that we've gotten kind of more than MVP functionality of what we're building to figure out what dashboarding will work best for all this data, whether that's Hygeia or something else. But Hygeia is an interesting tool if you haven't looked at it before. And one more slide. Oh yeah, we're hiring. So that's our taco truck, Barb, the Booz Allen recruiting bus. You might see her around town from time to time.
So thank you for listening.
Questions?
Yes.
In hindsight, what was the most painful part of your work here?
So Jenkins.
Working with Stephen.
Yeah.
Maybe names.
So Jenkins is an awesome tool because it's so flexible and configurable.
Yeah.
And Jenkins is an awful tool because it's so flexible and configurable. I think a lot of the challenges we've had, so after implementing it a few times at a few different engagements, we saw these patterns and said, how can we pull this all together into this reusable framework? And we knew programmatically, like this is template method design pattern, we can do this. Jenkins is serializable so that if it crashes in the middle of it, you can restart it. That has implications on the kind of code that you can write. So there was a lot of, if we go all the way back to that really complicated slide around all the hard stuff, like this was the most painful part of we need to construct this in a way that the different tools that get loaded in the pipeline don't know about each other, right? So developing these layers of abstraction and then keeping them in mind while we develop the integrations of the different tool sets so that it truly is a plug and play functionality. There was a lot of thought that went into those abstractions and how the different pieces communicate with each other so that they can be swapped in and out.
So I would agree on the technology side, but I think there was a bigger challenge on the people side of just finding people who are able to think in this way with Jenkins and implement this kind of model that we knew we needed. You can't just grab a random Java developer and expect them to be able to do metaprogramming in Groovy and integration with all these DevOps tools, which makes it really difficult, which is why the you can but is there, is that there's a people problem of a lot of upskilling needed.
It's a unique skill set to be on the border between I'm writing application code and doing software engineering, but I also need to have this really complex OpenShift and Kubernetes and cloud and Jenkins Groovy. Like, who here is an expert at Jenkins Groovy? I wasn't either. So you're sort of right in the middle between software engineering and ops, almost like it's DevOps.
And I want it to work for any target and any app and any programming language.
Yes.
And not even necessarily apps.
And I think that this is a little bit of a different space. When you implement DevOps at a startup, you have 5 people, and you don't have to worry as much about what is my organizational governance and what is my ATO timelines. It's definitely a concern and something that you worry about. But this scale is, I am an entire government agency. I need to define the business processes and how they're represented in my software development, and then come up with a solution that lets me use it regardless of tech stack, where you have a very diverse set of tools being used from mainframes to Kubernetes. Yes. Yes.
What were the limitations or gaps you saw in Hygeia that you're evaluating an alternate, or you never got into fully exploring Hygeia?
Hygeia is an interesting solution. So the question was basically what were the gaps or limitations in Hygeia? So I don't know that I'd call them limitations necessarily. It's just there may not have been as much upfront design and architecture work put into Hygeia at the beginning. So there's different plugins for Hygeia are configured differently, hook up differently, deploy differently, secrets are stored differently, right? So there's some challenges just around deploying and configuring it for all your different plugins. And then the kind of boundaries and APIs can be a little difficult. But it is really the only open source DevOps dashboard currently. It all ties back into basically how they use Grafana, which is what you'd use for building your own dashboard out. So we're exploring. There's some folks we've been talking to who have made kind of a fork of Hygieia to address these things. There's some commercial companies. CloudBeast has got DevOptics now, which might be interesting. So we need to go back now after a year and a half and reevaluate kind of the dashboarding space and see what works.
So how are you enforcing that each project team, when they check their code in, it automatically triggers your pipeline?
Sure. So inside, and this was actually one of the modifications or enhancements that we made to Jenkins, is there's a plugin that lets you use a single Jenkins file for an entire repo. We extended that to be able to use a single Jenkins file definition for an entire GitHub organization. So right here, we have our GitHub organization job. So every single repository within our GitHub organization automatically gets registered inside of Jenkins. And then every time you do something in Jenkins, it's going to trigger a Jenkins job based on a webhook. So if we go look at these specific jobs, we have a different job for every branch and pull request. And if we go back to that pipeline definition, that's where this comes in, where you've got all these discrete jobs for every branch and PR, but they're really acting as one to be your software development branching strategy and business process. So this was a challenging piece in and of itself, is how do I know what happened when, and then orchestrate different things, treat Jenkins like a state machine to orchestrate that.
Did you find it was really hard to get everybody to then build and deploy the containers in a consistent way for thousands of developers to utilize this? Or?
I think that's one of the value gains with the solutions delivery platform, is that it comes with best practices baked in. So it's very configurable, but if there are things that have to be done in it, it's because our experience with all of these different clients and different development teams is that this is the way to tag your images, for instance, such that they're traceable, or that we're able to do it designed infrastructure as code.
We don't really control, as part of the SDP though, what your container or what your image looks like, right? That's kind of outside of the boundary of what SDP is concerning itself with right now. That's more of something you can do with like the OpenShift registry, right? Is say, this is our blessed gold image for Spring Boot, right? And you will use this image. We kind of try to not concern ourselves with features and functionality that are provided by the underlying platforms, and that I don't actually care what platform you're deploying to, right?
Right. So actually, having used it, the discipline end up becoming, everybody as they build a repo would build a Docker file, basically, to say this. In the implementation we did, it was all containers and OpenShift or whatever. So everybody built a Docker file. And once you were kind of confident that you could build a Docker file that would execute well, then you were just pretty much done. You just put that in there, and through the organization and stuff, they picked it up and got it to OpenShift and got it to the place where you needed to run it. So
But as an organization, they're right. If you've adopted this, right? If you've adopted OpenShift, you're going to have those gold loads, and your Docker file or image specification file is really just going to say from Spring Boot, like from IRS Spring Boot, and then here's my source, and then that would probably be it, right? Because you're complying with everything else from the agency. Does that make sense?
Yeah.
On your pipeline, are all your tools running? Is it a requirement to run as containers, or can they run external?
So Jenkins, there's no requirement around what gets built and deployed, but each of the tools that Jenkins leverages gets run inside a container image.
So they have to be containers.
Well, they don't have to be. It could be, you can write either a configured version of each of the libraries that get plugged in. That'd be feature development, but it would be possible to install the tools on Jenkins without Docker. Currently, as it is now, all of the tools are run inside container images.
So we've seen a lot of benefits from that, right? When we're able to treat, we basically packaged this SDP thing and all the surrounding community of tools to run on OpenShift with a bunch of Helm charts and infrastructure as code we've created, right? which means we don't have to go out and manage individual servers anymore, and when they go down, they automatically get relaunched. So you could package this up as a solution for even somebody who's not using OpenShift for their deployment environment, and say, this is your build cluster for OpenShift. It has all the tools that you need. Just deploy it as almost an appliance, right?
I have been places that have 3 different versions of Java and 3 different versions of Maven in your build tools, and it's very challenging to manage the infrastructure as code for a Jenkins instance that sort of becomes Frankenstein with all of the different tools that need to be installed and make sure there's no collisions around it. And,
Yeah, there's
it's a challenge.
There's a lot of really cool advantages when you start running Jenkins as a container and all the build agents as containers, right? Because now I don't have to manage all these different versions of tools on individual agents. Instead, the Jenkins agents are running as containers themselves. I just swap those out depending on what tools I need to use.
Yep. So here we've got 4 Jenkins agents. Each of those 4 Jenkins agents corresponds to an OpenShift pod. They're actually running Docker and Docker to be able to run the tool images, which is beneficial because then you can do things like do privileges and cgroup limitations around those build agents themselves, and you get better cluster stability.
Is this something you're going to open source or have as an offering?
So,
We'll sell it to you.
yeah. So at the moment, we're working through those conversations internally and with some of our partners to figure out how we might distribute this. That said, if you already have a contractual relationship with Booz Allen, it's something that we might be able to deliver already. Otherwise, it's really a consulting engagement, right? But the firm itself is finally coming out with an open source policy in a few months, which is exciting for us, right? We can finally release code without violating our own internal ethics of like not leaking intellectual capital, right? So it will be interesting to see what we're able to open source without a whole bunch of approvals all the way up.
You mentioned having some problems with Jenkins and building this. A lot of the newer tools like GitLab has a CI which has a lot of these security tools built in. What are your thoughts on building this with like a GitLab CI tool as compared to using Jenkins?
So Jenkins is a very powerful tool in that you can really do whatever you want, right? So you can use Groovy to program what you want. You can access a large community of tools and plugins that are already written, right? When you start wandering into the commercial space of these tools, you obviously have less a community, you have less extensibility. When you then go into a tool like GitLab is kind of in between, right? You can't quite add all the same tools that you might want to, or they have to have certain kinds of endpoints for you to be able to work with them. So I think this model could be employed to other CI tools. We've also talked about building it standalone from any kind of CI tool at all. But for the moment, I think it's working pretty well for us to use Jenkins and rely on that tool and all the work they've already done in scaling and community.
Yeah, the other thing I would say is that a lot of those other tools are defined via YAML files that say this is my twist-lock portion of my pipeline. So trying to find that at an organizational scale, how do you swap them in and out? With Jenkins, you had a lot more flexibility with the programming. So I'm sure that if I had one repository and I wanted to build a pipeline, I might not pick Jenkins today. But when I need to scale to potentially thousands of development teams, this gave us more options from a software engineering perspective. I think we are just about out of time, though. But I love talking about this, so if you go to the happy hour after, let's talk.
Happy hour mission actually started 15 minutes ago.
So there's no more drinks? They're out?